Alright guys, we are going to add to our brand new chapter today. So we are going to be talking about polynomials. So on these first few pages here, we're just going to do some introductory stuff. We're going to call it Intro to Polynomials. We're doing this on 50 to 52. We're going to be talking about how we name them, how we add and subtract them, and how we multiply them, and kind of what they are. So just to kind of show you how this is arranged, and then I'm going to fill this all out with you. But on page 50, we have this little sheet here, which I folded in half. And then on the next page, 51, we have this one here. And then on 52, we're going to have two folded in half sheets, one with adding and subtracting, and then the other with multiplying polynomials. So let me put that aside so I can fill this out with you. I'm going to start with the one that said polynomial or not. And actually on the back of that, I'm going to write what I had above it. So let's talk about the definition. What is a polynomial? Basically, oh my goodness. I spelled it wrong. What is a polynomial? Kind of in the word, it's telling you what it is a little bit. Like I know in science class you guys talk about like prefixes and suffixes. We have that in math too. So this poly, you've probably heard before because polygon. The polygon is a many-sided figure. That poly word or poly prefix means many. Nomial means terms. It's just a fancy word for terms. And terms in math are just like numbers or letters or number letters being added up. And so this is just saying a many-termed thing. And then kind of the proper definition is a polynomial or a many-termed expression or equation in some cases with no negative or fractional exponents. So the thing is, when we're thinking about polynomials and like specifically what we're going to be doing with them today, like adding, subtracting, and multiplying, you really want to pay attention to the exponents anyways, because like when I want to add or subtract, I have to add up like terms, and like terms have the same exponent. So like it's all about the exponents. You really need to pay close attention to those because they're going to kind of tell you what's what. And the same thing goes for just determining if something is a polynomial or not. I need to pay attention to the exponents because if there's negative ones or fractional ones, it's not a polynomial. Now, kind of the way that we like to write a polynomial, if we can, is in standard form. So standard form looks like this scary business: ax to the n plus bx to the n minus 1 plus cx to the n minus 2, and so on and so forth until we get to something without any x's potentially. And so the a, b, c, z, those are all just numbers that would normally be in front of our letters. Then we have our variable x. And then this power stuff that's going on here is just showing that I'm going in decreasing order. So I start with a big one, and then I do one less, and then I do two less. So it's just going in decreasing order, which is how we write stuff in standard form, if you remember from last chapter. But really, it's kind of nicer too when you can put a polynomial in factored form. Also, if you remember from last chapter, it was really nice to have stuff in factored form because it shows me my answers right away. So factored form is where we have like a parenthesis x minus r sub 1, x minus r sub 2, x minus r sub 3, and so on until I get all of the answers in there, or all the x-intercepts in there. And like the reason we use r is just r kind of stands for root, and root is just a fancy word for our solutions. So looking at the inside of this now, I would normally have you take a pause and try to pick out the polynomials for yourself, which if you want to do that, you absolutely can. I'm going to kind of go through right now and shade in each polynomial. And then if something is not a polynomial, I'm not going to shade it in, and I'm going to show you why. So the first one is totally a polynomial. Now, it's a bummer that they're not going in standard form because they're going in increasing order, but it's still a polynomial because those exponents are all fine. And the dot, dot, dot is just showing me that I'm going to continue forever going up by ones. So we don't have to worry that there'll be a hidden fractional exponent somewhere later. Which, speaking of those, the next one is not a polynomial because of that fractional exponent. Now the one underneath it, that one is fine. Our exponents are 4 and 1. I know we don't like a fraction at all, but this fraction is just a number, so that's fine. However, the one after that is no good because we also cannot have negative exponents. Which, speaking of negative exponents, there's maybe a thing that we remember from Algebra 1. Here I have 3 divided by x. And looking at the x right now, it seems fine. But when you're actually dividing an x, truly x has a negative exponent at that point, making it not a polynomial. So it's kind of hidden, but it's not a polynomial. 12 all on its own is a polynomial. Even though there aren't many terms and there are no variables, that's okay. This is a polynomial. You can kind of imagine there's an x to the 0 power, which would just be x, that would just go in, it's 1, making this just 12. So yeah, and 0 is fine. This next one though, the root feels weird, rightly so, because the square root can also be written as a power, and its power is half. So this is not a polynomial because of that sneaky half power, that sneaky root. But 5x plus 1, that's a polynomial. That's all good. Also, if you glance at x to the 4 over 2 power, you might be like, oh, fraction is no good. But, 4 over 2, that's just 2. So this is really fine. That is a polynomial. Next one, totally fine. That's a polynomial. Down here, though, I have that other sneaky denominator x, so that would make this truly negative, so not a polynomial. And then this last one, that one's all fine. That one's a polynomial. X is negative, but the exponent's not negative, so it's all good. So there we go. We got some examples of polynomials and non-polynomials. Okay, so let's turn the page and look at some adding, subtracting, and multiplying. There was this other page here. I'm going to fill that one out at the end. Okay, so starting with adding and subtracting, we want to know how to combine polynomials with each other. Basically, to know that you're adding and subtracting, you're going to look in between parentheses. If there's a plus sign, you're going to add, which basically means you don't need the parentheses. So drop parentheses, just add. If you look in between the parentheses and you see a subtraction sign, though, you do have to be a little bit more careful. You should distribute the negative, then add to that second set of parentheses. Now the thing is about addition and subtraction, though, you do have to be a little bit careful. They're very picky. You can only add like terms. And what I mean by a like term is the exact same letter or letters and the exact same power or powers. So same letter, same power. And that's how I'll know that I can add them up or subtract them. So looking at this first one here, I notice we're subtracting. So I would distribute my negative in and drop the parentheses on the first. Which when I combine all those, we just have negative 10. Now the thing is, polynomials have names, more specific than just polynomial. And so they kind of have a first name, last name, just like we do, Marissa, Missouri. So this polynomial right here has a first name of constant and then a last name of monomial. Now the monomial is because I'm just one. Constant is because if you think about graphing this, it's just a flat line. So that's kind of what helps me think of constant. Looking at the next one here, we're just adding, so I can kind of just ignore the parentheses and combine my like terms. So we'll have 14x plus 6. And so this one is not constant or a monomial. Now I have to the first power thing, and like if I think about graphing this, it would be a line. So we are a linear, and then two terms is binomial. Looking at the next one, we are also adding, so I can kind of just ignore parentheses, and then I'm looking for exponents that are the same. So like 3x squared plus 4x, and then plus 2. And then if I think about naming this one, it's not like any of the others. Now if I think about graphing this, this is quadratic. That was what we were just doing. So quadratic trinomial, because 3. Okay. This next one here, we are subtracting, so I'm going to want to distribute that negative. And then I would combine my like terms, so I'd have negative 2x to the third minus 35, which to the third we haven't really talked about yet. Maybe we remember from Algebra 1, but maybe not. To the third thing is called a cubic. And when we had 2, that was a binomial. Next one, I have to distribute again, so I'm going to change all those signs on the second one. And then we want to look through, and I always like to find the biggest power because I want to write it in standard form if I can. So like 4 is the largest, so I'm going to have negative 2x to the fourth. Then I'm looking for a to the third thing, and I do have one, but nobody to combine it with, so it's just coming down. And then I look for a to the second thing, and nobody to combine it with, so it's just coming down. Then I look for just plain old x, and I don't have one of those, so I skip it, and I just go to my minus 8 at the end. Now this one has a new power that we have to talk about here. It's not cubic or quadratic. To the fourth power is quartic, like quarters maybe, 4 quarters in a dollar. And then once I get to 4 terms, unfortunately we don't have any more cute names for our nomials. They're just going to be plain old polynomials. Next, we have addition, so I can just combine up like terms, and we got 10x to the fifth, and then none. So to the fifth thing is a quintic. Only one term is a monomial. And last one that we got here, which is a real big one, we do have to distribute the negative. So first part is all going to stay the same. But the second part all had to change. And again, I'm going to go through and I'm going to look for my biggest exponent, which is a to the sixth thing. But I don't think there's anybody to combine it with. Then I look for it to the fifth thing, and I also don't think there's anybody to combine that with. To the fourth thing, and I do have negative 11, negative 1, so negative 12, x to the fourth. Then I'm looking for it to the third thing, and I can just bring that down. To the second thing. To the first thing. Nope, and then a non-x thing, so just negative 8. So that is a really wild polynomial. It's truly just a polynomial because there's too many terms for a fun name. And also, once we get bigger than 5, our degrees don't have fun names anymore either. We just call it a 6th degree polynomial. Or like if the highest power was 10, we'd call it a 10th degree polynomial and all that fun stuff there. So that's how we add. Pretty easy stuff, I think. What's maybe a little bit trickier, and kind of how we name, is multiplying. So looking at multiplying, we want to know that we're multiplying by looking in between those parentheses and there's nothing there. They're just smushed up together. And then you really just want to think about FOIL, or like make sure you multiply everything, combine those like terms, and make sure you put it in standard form. So I mean, most of this we already know, which hopefully makes this pretty easy start. So like this one I straight up can FOIL, like first, outer, inner, last, or distribute twice if you prefer that with the arrows. And so like x times 2x is 2x squared. Then we get a 7x. Then we get a negative 6x. Then we get a negative 21. Next, I want to combine like terms. So we'd have 2x squared plus 1x minus 21. And then I can name it. The degree is 2, so quadratic. There are 3 terms, so trinomial. Now looking at the next one though, that one is not as nice. And it's not as nice because we are doing 2 things times 3 things. So I could take the arrows, so like starting with the 2x and arrow, 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 arrow. But I always feel like there's a lot of room to lose a number in there. So another way to do this that I think is a little bit more organized. Now you can still do the arrows, that's fine. I always like to set up a Punnett square box, or really a Punnett square rectangle, and put my 2 numbers on the 2 side and my 3 numbers along the top side, this 3 side here. And then I just multiply to find each box, and then I can go through and combine like terms after that. It just ensures that I don't forget a number because I have to fill each square. So when I multiply here, I get 2x to the 3rd. When I line these ones up, I multiply and get 10x squared. Then I multiply here for 8x. Then we're multiplying down here for negative 1x squared, negative 5x, and negative 4. And then we can kind of go through and combine like terms. So we have, and I'm going to put it in standard form, so 2x to the 3rd. But then these diagonals are the same. So plus 9x squared plus 3x minus 4, which this is a cubic polynomial. Looking at the one after that, that one is also tricky and different because you are multiplying 2 by 2 by 2. So really what you're doing there is you're multiplying 3 numbers. Like let's say you were multiplying 2 times 5 times 4. You would never be able to do it all at once. You're always going to think about it like 2 times 5 times 4. Or maybe like 4 times 5 times 2. But you're always going to have to do 2 together first before you multiply the 3rd. And so you have to do that here as well. So I would multiply the first 2 first. So like maybe I FOIL those real fast. So like 2x squared, and then 14x and 3x for 17x, and then plus 21 at the end. And then now I have to bring this x minus 1 down that I didn't do yet. And now I'm looking at a problem just like the last one where I have 3 numbers by 2 numbers. And so maybe I set my rectangle up this way now. It really doesn't matter how you set it up. But my 2 numbers across the top are x minus 1. And my 3 numbers across the side, we got 2x squared, 17x, 21. Then we multiply just to get each of these squares. So 2x to the third, negative 2x squared. 17x squared, negative 17x. 21x, and then minus 21. And then we can kind of go through and put it in standard form and collect our like terms. So we got 2x to the third, 15x squared, 3, 4 x, and then minus 21, which this is a cubic polynomial again. So that's fun. And then the last one is just a little bit different too. It really is the same as the last one. It just looks different. Because if I have x plus 5 to the second, really that just means I have it twice. And then I have to multiply by the x squared minus 4 at the end. So again, we would do it the same as the last, where I'd FOIL here. So x squared, 5x is 10x. And then 25 at the end. And then we could set up a box, or I could do the arrows. We could do that, where like this goes to both of these. So like x to the fourth, and then negative 4x squared. And then the 10 goes to both of these. So plus 10x to the third, minus 40x. And then the 25 goes to both of these. So plus 25x squared minus 100. Now the only reason maybe to argue for the box is like it kind of puts things close together. Like I can see my like terms really fast. But this isn't so bad. So x to the fourth is the largest. Then I have a 10x to the third. Then I have some x squareds to combine, so 21. Then I just have a negative 40x, and then my minus 100. So definitely a polynomial, and it's to the fourth power, so quartic. E. All right, so last but not least, on that previous page where we had naming polynomials, this is just where we're going to compile all the names that we came up with. So if we are just a 0 degree, so just a plain old number, because we have x to the 0, that is a constant. So these are all my first names based on my highest degree. If I have an x to the first power, that is linear. If I have something to the second power, that is quadratic. If I have something to the third power, that is cubic. So it's all based on our exponents. So that's a low-key one. If I have something to the fourth power, that is quartic. 1, 2, 3, 4, 5. Am I missing one? Oh, no. And then if I have something to the fifth power, like losing my noggin, we are quintic. And then if I have anything greater than 5, you just call it a blank degree polynomial or whatever. So if you're greater than 5. Okay, so those are all of our first names. Our last names are based on the number of terms or the number of numbers that we have. And so if there's just one, like I had here and here, then it is a monomial. If there are 2, like I had here and here, then that is a binomial. And if I had 3, like I do here and here, that's called a trinomial. And then anything more than 4, or 4 or more, so more than 3, is just going to be a plain old polynomial. So just so we have all those names compiled in one place, and there we go.